3.7, Polynomial and Rational Inequalities. If I recall, today we don't have too many examples, it's just that they are very long. Let's see. So in section 1.7, we saw basic inequalities. In this section, we saw more advanced inequalities by using the methods we learned in section 3.4 for factoring and graphing polynomials. So, again, I will put this kind of algorithm of solving polynomial inequalities up here, but I'm not gonna follow it step by step. Okay. All right, so polynomial inequalities. An important consequence of the intermediate value theorem is that the values of a polynomial function p do not change sign between successive zeros. In other words, the values of p between successive zeros are either all positive or all negative. Graphically, this means that between successive x-intercepts, the graph of p is entirely above or entirely below the x-axis. I need to get figure 1 so you can see what we're talking about. Okay, so notice how if you recall, right, we did things where we built a little wall, and then we determined the interval and then chose a number in the interval. Okay, so to the left of that red line, okay, notice how all those values are above the x-axis, right? And then this blue line here, I'm going through another, all right, so by the way, I'm going through these x-intercepts here. Okay, so notice how as I'm going through that second x-intercept, all these values here of the graph right here are below 0. And of course, we can see that was a pattern, and that's what that's saying up here. Okay. This property of polynomials allows us to solve polynomial inequalities like p of x is greater than or equal to 0 by finding the zeros of the polynomial by using test points between successive zeros to determine the intervals that satisfy the inequality. We use the following guideline. Now, the following guideline would be over here, but like with all the algorithms in this textbook, or the step-by-steps in this textbook, I mainly just, again, I feel like when I learned mathematics, it was just always easier for me just just hear what the professor had to say and just follow along that way. Okay, and again, I'm going to be following this. I'm sure I will, right? Yeah, I'm going to be following through this, and I want you to also follow through it. But at the same time, don't focus on rigorously memorizing these 5 steps word for word, because you're just using up memory, right? You're using up your memory. Whereas if we just do a step-by-step process that is logical, then we can arrive at the same solution without having to memorize these 5 steps, which we will be doing though. Okay, we will be using the 5 steps. So I'll quit my rambling and actually do it. So solve the inequality. 2x cubed plus x squared plus 6 is greater than or equal to 13x. Okay. So we are going to move everything to one side. So we'll have a 2x cubed plus x squared minus 13x plus 6. And that is greater than or equal to 0. Okay, so keep that in mind. Greater than or equal to 0. We're going to be coming back to that. Okay. All right. So this problem, it may or may not look familiar to you, but this is example 2 in section 3.4, and this is 3.7. So if you have 3.4 notes, we factored this into x minus 2 to 2x minus 1, x plus 3. And that is greater than or equal to 0. Okay. Again, this was Example 2, we'll do that. We'll put it over here. Example 2. In 3.4. Okay, you can't really see that 4 because for some reason I've decided to write white on white. All right, there we go. So this is what we factored this polynomial into in example 2, section 3.4. So now let's make a number line. Okay, obviously infinity is this way. Negative infinity is this way. Probably should have given our zeros first, huh? Okay, so our zeros are at what? It looks like x is equal to a positive 2, at x is equal to a positive 1/2, and at x is equal to a negative 3. Okay, we have to get our zeros out of the way. That way we can put up our walls. Okay, so we'll have a, because it doesn't matter. I don't really like that 1/2. Okay, so what we're going to do is this. Let's erase this. Oh, I guess we can erase all that line. So it doesn't matter necessarily, you know, if we draw the number line to scale, right? Because the scale is not what matters. So that's why I was kind of going, well, this maybe that. Okay. Okay. What matters here is that we denote points on a line that are our zeros. Okay. So we will call this first dot, we're going to call that a negative 3 because as we're going left to right on a number line, is be negative 3. Next up would be 1/2. And then lastly, we'd have a 2. Okay, so these are our boundary lines. So I'll make them thin. They're thin boundary lines. Okay, so if you recall when we did this, I guess it was section 3.4. What we're going to do is we're going to get a test point. Okay, so this interval to the left of negative 3, let's see, this interval over here, okay, that would be from negative infinity to negative 3. This interval in here, that would be from negative 3 to a 1/2. Yeah. The computer doesn't register small 3's really fast. This interval here would be from 1/2 to a 2. And then this interval over here would be from a 2 to an infinity. So, recap, what I did was I factored my polynomial. Once I factored my polynomial, I got my zeros, which are here. Once I got my zeros, I made my number line and denoted my zeros. Okay, and then once I did that, I found my intervals inside between each one of those zeros. Okay, now what we have to do here is we have to figure out. There's two ways to go about this, but and this might be the only time I actually like what this textbook does, is we're just going to do the intermediate value theorem, and we're going to look at the signs. Okay, so we're going to have to choose a number. Let's make it blue. We'll choose a number in this interval over here. This one right here. Okay, from negative infinity to negative 3. Okay, what is a number from negative infinity to negative 3? Well, that we can just choose the number to be negative 4. Okay, from negative 3 to 1/2, I've told you that if you have the number 0 available to you, always use it. So 0 it is. From 1/2 to 2, well, if you have the number 1 available to you, always use that as well. Okay, so we're going to use 1. And then from 2 to infinity, we're going to use 3. Okay, So again, all I did was choose a number that is in these intervals. Okay, if you have negative ones, zeros, and ones available to you, use them, because what we're going to do is we're going to plug these numbers in, these numbers, we're going to plug them into this, or really this inequality. Doesn't really matter which. Actually, it does matter. It only matters for simplicity. We're going to plug them into this one. Okay, mainly because we're gonna go by the even, odd signs. So what do I mean by that? Well, let's do this. Okay. So first thing, let's go ahead and plug in a -4. Okay, so if we plugged in this -4 up here, okay, so we would have a -4. So let's how can I write this? Okay, I'm gonna use a big old like plus or minus sign. Okay, like that. Okay, so here's what we're gonna do. So -4. If I plugged in a -4 here, -4 minus 2, that is a negative symbol. 2 times a -4 is a -8. Minus 1, well, that's a -9, so that's going to be a negative sign. And then -4 plus 3 is also going to be negative. Okay, so that's all the computation I have to do, because now we can do what? We can say, okay, so a negative times a negative. All right, a negative times a negative is a positive, and then a positive times a negative is a negative. Okay, hopefully you followed along. If not, we have 3 more tries. All right, so we did negative, negative, negative. We plugged in -4. A negative times a negative, doesn't matter what the negatives are, is going to be a positive. Okay, so these two turn into a positive, and then a positive times a negative is going to be a negative. Okay, and a negative number is not greater than or equal to 0. Okay, so it's not greater than or equal to 0, so I can say that this interval is not part of the solution. Okay, well now let's use a 0. So if I plugged in a 0 here, a 0 here, and a 0 here, okay, so a 0 minus 2, it's a negative. 2 times 0 is a 0 minus 1 is a negative. And then a 0 plus 3 is a positive. Okay, well again, here we go. So a negative times a negative, that gets me a positive, times a positive, right? So that means that my test point 0 gives me a positive number, which is what I want. I need it to be greater than or equal to 0. So this interval works. Let's go on again. So we're going to plug in a 1 in for my x's here. Okay. So 1 minus 2, that's a negative. 2 times 1 minus 1. 2 times 1 is 2 minus 1. That's a positive. And then 1 plus 3 is also a positive. Okay, well, we have an issue here, right? So now we've got a negative times a positive. That's a negative. And then we would have a negative times a positive again, which would again be a negative. So this interval does not work. And lastly, we're going to plug in a 3. So we plug a 3 here, a 3 here, and a 3 here. So 3 minus 2, well, that's a positive. 2 times 3 is 6. 6 minus 1 is 5, so that's a positive. 3 plus 3 is 6, so that's a positive. Well, a positive times a positive, positive times a positive times a positive is going to be a positive. So this interval works. Again, I'm wanting to make sure that I'm greater than or equal to 0. We're going to have a problem later on in today's lecture where we have a less than, and we're going to be looking for numbers that are less than 0. But for this one, we're looking for numbers that are greater than or equal to 0. And that only appears when we in the intervals from -3 to 1/2 and from 2 to infinity. Okay, so my solution set, I'm out of space, so I'm just going to run the example again. So my solution was from -3 to 1/2 and from 2 to infinity. So how would I write that? Well, I would say from -3 to 1/2 union with 2 to infinity. Okay, but wait a minute. This particular problem, it has greater than or equal to sign, right? So I'm going to use brackets instead of parentheses. So we're going to like this. But we're going to leave the parentheses on infinity because, again, infinity is not a number, it is a concept. So we're not going, to an exact number, we're going to an exact concept, which would be infinity. Whew. All right, well, that's example 1. All right, I told you today, I think we're doing like 4 examples, and they're all that tedious. So let's do this again. All right, so this is one that does have a less than, so let's get this started. So we're going to move everything to one side again, and we're going to put a descending order. So we'll have a 3x to the 4th, and it looks like it's going to have a minus 2x cubed minus x squared minus 12x, and then minus 4. It's less than 0. Right. So similar to example 1, this is example 5 in section 3.5. So this is example 5 in 3.5. So we factored this again in 3.5. If you want to see it, go back and watch that lecture again. This factors into x minus 2, 3x plus 1, and x squared plus x plus 2 is less than 0. Okay. So what are my zeros here? Well, if you recall, let's see, if this was example 5, pretty sure, no, forget that. Okay, so what are my zeros? I have zeros at 2 right here, at negative 1/3 right here, okay, and then this doesn't have real zeros, okay. We can't factor that. We would use our quadratic formula, and our quadratic formula would get us to 2 imaginary numbers, okay. So my zeros are only at 2 and negative 1/2. So let's go ahead and make a number line here. And again, we could, if you wanted to, and I wouldn't, we could, go ahead and make the number line 0, 1, 2, 3, so on and so forth, right? But it is honestly easier if we just, we don't care about those other numbers, right? So we're just going to denote this to be negative 1/2 and this one to be the positive 2. Okay, so let's do it like this. So negative 1/2. That is really crisp, nice and thin. Okay, so, and then a 2. Okay, and then we're going to have our boundaries once again. All right, so what I'm going to do is I'm going to choose a number in this interval, okay, and this interval is what? This interval is from negative infinity to negative 1/2. This interval in the middle is negative 1/2 to a, you wrote negative 1/2 instead of 1/3. I did, thank you. That would have been an issue. Thank you. So this interval is from, oh, this one up here too. Okay, here we go. Try again. All right, so this middle interval is from negative 1/3 to 2, and then this last interval is from 2 to infinity. Okay. And once again, we're just going to get a test point. So from negative infinity to negative 1/3, well, I've got negative 1 available to me, so we're going to plug in a negative 1 here. From negative 1/3 to 2, that's easy, 0, always, right? And then from 2 to infinity, 3. Okay. So now let's go ahead and do the whole plugging in thing again. So we're going to plug in a negative 1. We'll make it like we did last time. All right, so here we go. -1. If I plug in a -1 here for this one, -1. Again, I'm putting a -1 here, -1 there, -1 there, and -1 there. Okay. So the first one, -1 minus 2, that is a -3, so that's a negative. 3 times a -1 is a -3 plus 1, that's going to be negative. Okay. And then we've got a -1 squared, that is a positive 1. A positive 1 plus a -1, well, that is going to be a, when I say positive 1, they're going to cancel out, and then plus 2 gives me a positive number. Okay. So now I've got a negative times a negative times a positive. Well, negative times negative is a positive, and then a positive times a positive is also a positive. Okay, so what this tells me, okay, so last time I was wanting our numbers to be greater than 0, greater than or equal to 0, right? So I wanted numbers that were positive. This time I'm wanting things to be negative, right? Because it's a less than 0. So if I had a negative times a negative got me a positive, and that positive times a positive got me a positive. Well, a positive is not greater than, is not less than 0. So I would say that this interval does not work. Okay. Now let's do 0. Well, 0 minus 2, that's a negative. 3 times 0 plus 1, that's it's going to be a positive. And if I plug a 0 here and 0 in there, I've also got a positive. Okay, so now I've got a negative times a positive gives me a negative, right? These two give me a negative, and then these two also give me a negative. Okay, so that's what I want. I wanted a negative number, right? Because again, I'm looking for values that are less than 0. So this interval works. And then lastly, we have 3. So 3 minus 2, that's a positive. I plug in, that's 9, that's 10, that's a positive. And this is positive. Well, positive times a positive times a positive is a positive. And again, I'm not wanting a positive. So this interval does not work. So the only interval that does work is that middle interval from -1/3 to a positive 2. And similar to the last problem, I'll just go ahead and re-snip and do this on a new slide. -1/3 to 2. Okay. And yes, we do use the parentheses here because it is a strictly less than symbol. Alright, so rational inequalities, we're going to do it kind of the same once we get past the beginning part. And I bet I should probably go ahead and snip this figure. Okay, here we go. So, unlike polynomial functions, rational functions are not necessarily continuous. The vertical asymptotes of a rational function R break up the graph into separate branches. So the intervals on which R does not change sign are determined by the vertical asymptotes as well as the zeros of R. This is the reason for the following definition. If R of x is equal to P of x divided by Q of x, a rational inequality, or rational polynomial, is a rational function, the cut points of R are the values of x at which either P of Q is equal to 0 or P of x is equal to 0 or Q of x is equal to 0. So what this is saying, we'll read. In other words, the cut points of R are the zeros of the numerator and the zeros of the denominator. Yeah, that's exactly what we're about to go into, okay? So, same procedure here, although it doesn't necessarily say it for this one, but you must have simply one rational polynomial. Okay, what I mean by that is you cannot do a 3x over x plus 4 minus x squared over 9 is greater than 0. you have to have a singular rational polynomial. Okay, and of course we will have an example of this coming up. Guess it'd be the last example. Okay, so. Alright, so what we need to do is we need to put everything to one side. And actually, this example does actually show what I wanted to do. Alright, so we put everything to one side. So we're going to have a 1 minus 2x over x squared minus 2x minus 3 minus 1 is greater than or equal to 0. Okay, so yeah, I was right. It was this one. We need to have one single rational polynomial on the left side. Okay. Notice we do have a rational polynomial. Well, we have one, I guess, but we also have this minus 1 right here. Okay. What I need to do is I need to combine both of those into just one fraction. Okay. So how do I do that? So this first page is going to be dedicated to doing that. So let's rewrite the left one. We have 1 minus 2x over x squared minus 2x minus 3. All right, so how can I rewrite 1 as a number that's with a denominator of x squared minus 2x minus 3? Okay, well that's pretty easy, right? We just simply say x squared minus 2x minus 3 x squared minus 2x minus 3. Right? That makes sense? So all I did was I changed this 1 into this. Right? X squared minus 2x minus 3 over x squared minus 2x minus 3. Well, that is 1. Okay? So next step we're going to do is we're going to combine these two. Okay? Well, I want to say the hard part's over with. So we would say 1 minus 2x, okay, and then this minus sign here, so it's going to be minus, and we're going to put everything in parentheses behind it. X squared minus 2x minus 3 all over x squared minus 2x minus 3. Okay, we can put it all over that because that was really the point of getting this far. In one moment, I went a little overboard with my heater and I'm burning up. First time I turned the heater on, and it works. That's good. All right. So next, we're going to snip this and put it on the next page. Okay. So we need to clean up that numerator there. So we're going to have a 1 minus 2x. We're going to go and distribute that negative sign through. Okay, so we're going to say negative x squared plus 2x plus 3 all over x squared minus 2x minus 3 is greater than or equal to 0. Well, yeah, we'll just go and snip and carry on. I mean, I could write a little bit smaller, though. Well, yeah, this isn't the worst thing. All right, so once I do that, we can. It looks like my minus 2x and my plus 2x, they cancel. My 1 and my 3, they will combine. So we'll have a 4 minus x squared. Looks like we have a difference of squares, don't we? Over x squared minus 2x minus 3 is greater than or equal to 0. Okay, so let's go ahead and factor that numerator. So factoring that numerator, it is a difference of squares. Okay, hopefully you can see it. It is an a squared, right? 2 squared, which would be 4, minus a b squared, which is x, right? X squared. So this would be a plus b, a minus b, or it would be 2 plus x and 2 minus x. Okay, just the difference of squares. And then my denominator here, okay, that's my factors of 3, that factors into x plus 1 and x minus 3, and it's greater than or equal to 0. Okay, so we've now officially got to the point where we just do the same thing we did in example 1 and 2. Okay, so let's go and snip this to a new page, and we're going to get our boundaries, or we're going to do our line, rather. We're going to do our line. Oh, I didn't remember my x values. Okay, so my values of x here, okay, are, so just looking strictly for boundary problems here, or boundaries here. It looks like we have an x at plus and minus 2, so we have x. Oops. Okay, again, let's go back. This says right here we need to factor numerator and denominator, factor the numerator and denominator into irreducible factors, and then find the cut points. Okay, so once we factor it, we find those cut points being, where we solve our polynomial for 0 at, right? And this numerator, that when our x is equal to plus or minus 2, in the first one, if we have a minus 2, it's a 0. If we have a plus 2, it's a 0, right? So plus or minus 2, that's one of them, or 2 of them rather. X is equal to plus or minus 2. And then we've also got a negative 1, and we've got a positive 3. Okay, so I have to find the zeros of both my numerators and both my denominators. That's what I did. Okay, and then on the number line, so we've got, oh gosh, we got 4 of them. Okay, so going left to right on the number line, so we're going to say 1 here, 1 here, 1 here, and 1 here. Okay, so again, left to right, this one is going to be a negative 2, this one will be a negative 1, this will be a positive 2, this will be a positive 3. Okay, again, these numbers are just simply these numbers. Put up our boundaries. And write our intervals. So this interval is from negative infinity to negative 2. This one is from negative 2 to negative 1, negative 1 to a positive 2, positive 2 to a positive 3, and a positive 3 to infinity. Good grief. Okay. Well, let's get started. Oh yeah, we probably need to find a test point. What color are my test points? Put them in yellow. Okay, so I did it backwards. So my test point for this interval here, we'll use negative 3, negative 2, negative 1. Oh, nobody likes fractions. Negative 1 to 2. Oh gosh, more fractions. 2.5 is what, 5 halves? Okay, so here we go. Plugging in a negative 3. So if I plug in a negative 3, and I'm just going to go, I'm going to go plug in here, 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 and here. Okay, so I'm going to go left to right on my top and left to right on my bottom. So if I plug in a negative 3, this becomes a negative, this becomes a positive, this becomes a negative, and this becomes a negative. Okay, so my numerator, it's a negative times a positive, which is a negative, and then my denominator is a negative times a negative, which is a positive. So then we have a negative over a positive, which gives me a negative number. Okay, so hopefully you followed along. Just in case you didn't, I'm going to do it one more time. Actually, no, I have 4 other examples. We'll just roll, okay? So, again, negative times positive is negative. Negative times a negative is a positive. Negative over a positive is a negative number. What we're wanting is a number that is greater than or equal to 0, so we're looking for positive numbers, okay? So, this interval does not work. Next, we're going to have negative 1/2, okay? So 2 minus half, well, that's going to be a positive. 2 minus a negative 1/2, that's also going to be positive. And then a negative 1/2 plus 1, that's going to be a positive. And then we've got a negative 1/2 minus 3, and that's going to be a negative, okay? So I feel like I did something wrong there. Hang on one moment. Negative 1/2, so this is going to be positive. That's going to be positive. That's a positive, and that's a negative. So you have a positive times positive, positive over next. So this shouldn't be correct, but I'm thinking it is, because negative 1/2 should work. That's my issue. Negative 1/2 is not between negative 2 and negative 1. It should be negative 3/2. Negative 3/2. That's better. Sorry about that. So let's try it one more time. Okay, so a 2 minus a 3/2. Okay, so that's again 2 minus 1.5. That's going to be positive. This is going to be a positive. That's going to be a negative, and that's going to be a negative. Okay, so my numerator becomes positive. Positive times positive. My denominator is also a positive because it's a negative times a negative. So this interval does indeed work when you do the computation correctly. All right, next up we've got 0. So we've got 2 plus 0, that's going to be a positive. That's going to be positive. That's going to be positive, and that's going to be a negative. Okay, positive times positive is positive. Divided by a negative, well, that's going to be a negative. So this third interval does not work. And then 5/2. Okay, so 5/2 is essentially what, 2.5, right? So 2 plus 2.5, well, that's going to be positive. 2 minus 2.5, well, that's going to be negative. This is going to be positive, and that's going to be negative. Okay, well, we have a positive times a negative in my numerator, and that gives me a negative in my numerator. Okay, and then a positive times a negative in my denominator is going to be a negative in my denominator. Okay, well, a negative divided by a negative gives me a positive. Okay, so this interval does work. And lastly, we've got a 4. 2 plus 4 is 6, that's going to be positive. 2 minus 4, that's going to be a negative. This is going to be a positive, and that's going to be a positive. Okay, and again, we have a positive times a negative in my numerator, which is a negative. And my denominator is a positive. Negative divided by positive is a negative. And that does not work either. Okay, so here, and we can just go ahead and write my solution set. My solution set are where are the intervals where I see my green check marks. And I'm going to go ahead and write them in brackets because, look, we have a bracket there, right? So it's going to be from -2, well, we're equal to, right? -2 to -1. Union with 2 to 3. Whew. Man, I need a break. And the last one for the day what makes this so tricky. Okay, so looks like we can factor these pretty easily, right? My numerator factors into 3 and 1, both negative. And my denominator is 5 and 1. And 1's negative, only 5. So x minus 5 and x plus 1. And that is greater than or equal to 0. All right, well, this is already, pretty much done up, right? So what are my zeros at? Well, my zeros are at, we have zeros at x is equal to it looks like plus and minus 1, positive 3, and positive 5. So plus and minus 1, a positive 3, and a positive 5. So let's do our number line again. Okay. So again, reading a number line from left to right, we're going to do negative 1 here. Oh, we're still in line mode. A negative 1 here. A positive 1, positive 3, positive 5. So let's set negative 1, positive 1, 3, 5. So hopefully you're not bored. But anyways, what are my intervals at? Well, my intervals are at, all right, looks this interval here is negative infinity to negative 1. This is from negative 1 to a positive 1. 1 to a 3. Luckily, oh, that was very nice of the textbook to not give us fractions for this one, huh? Nobody likes fractions. Alright, so test points. Here we go. Test points. Negative infinity, negative 1. My test point's going to be negative 2. Negative 1 to 1. Always take that 0. Okay. These are my test points. Now let's plug them in. Same procedure as I did before. So negative 2. Alright, so if I plug in negative 2 up here, that's going to be a negative. That's going to be a negative. That's going to be a negative. And that's going to be a negative. Okay, well, that's pretty simple to me, right? Negative times a negative is a positive, and then a positive over a positive is also a positive, and what I want here is a positive number. So this works. If I plug in a 0, this becomes a negative, turns to negative, turns to negative, turns to, and this is a positive. All right, well, that is, okay. That is negative times negative is a positive. Negative times a positive is a negative. A positive over a negative is a negative. So this interval does not work. Next up we have a 2. We plug in a 2. So this becomes 2 minus 3. So that's a negative, positive, negative, positive. Okay, well now we have a negative times positive is negative in both numerator and denominator. And a negative divided by negative is also a positive, so this tells me that this interval works. All right, next we're going to go to 4. 4 minus 3, that's a positive, positive, negative, positive. So again, same thing. Do the arithmetic there, and we see that this interval does not work. And then the 6, so that's a positive, 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 positive. Good. So that's all positive. So this tells me that this interval works. So my solution set, again, we're going to be using brackets because it isn't greater than or equal to, will be, my solution set is from negative infinity to negative 1, unioned with 1 to 3, unioned with 5 to infinity. Oh my goodness. And that's it. I say that's it, but these are very tedious, but that does conclude today's lecture.